Okay. Well, thank you for the introduction, and it's nice to see that this room filled up with so many interested people. So thanks for joining this session. I don't know if there were people not present in the plenary session, but just quickly, TNO is an independent research organization founded in 1932, and we connect knowledge and people to create innovations, and we use them to help companies in the Netherlands boost the competitive strength, as well as strengthen the well-being of society. We're organized in 9 units currently. It's going to change, but let's not go into that today. And those 9 units represent the multidisciplinary focus areas we work on. I'm responsible for our unit traffic and transport and our office in Japan, but there's colleagues from other units also present today. So once more, quick overview, because we already did this in the last session. There's 2 roadmaps that TNO Traffic and Transport works on. So sustainable innovations on our sustainable roadmap and smart and safe innovations on the other side. We work on 3 levels, the mobility levels as we see them. So the vehicle level, creating innovations for vehicle OEMs and also for the government side of that. Mobility level, where we look at smart and sustainable mobility and logistics, emission legislation, but also logistics, self-organizing logistics, for instance, or data-driven logistics. And at society level, we bring everything together in a way that is fit for the well-being of society. So to make sure that the mobility solutions we create actually benefit society as a whole. Today's presentation, I'll be focusing on the vehicle level innovations. That is also the part that within Japan we work on most. But if you have any questions on the other levels, please come and see me during the drinks, and I will be happy to explain more about that. So, what's happening in mobility at the moment? I just now noticed that this has a Dutch text in it. That's not a good thing. We have to change that. But I think the picture symbolizes that we are in a transition phase. So we used to have all of these modalities, all of these transport means, vehicles, vehicle types that were optimized for our current mobility solution, or as we saw it, optimized, and everybody knows what they're using. But we need to go to a situation on the right that is totally different. Just some pictures here that might become truth, might not, like flying taxis or self-driving logistic robots. We need to go to new solutions, but we don't know exactly yet what those solutions will be, because there's a lot of uncertainty in the mobility field. What energy carriers will be available? What type of infrastructure will be available? What legislation will there be? Will politicians enable certain technologies or stop certain technologies? So we're somewhere in the middle there. And the word chaos is up there, which is also the same in English, because of that situation where we don't know yet what the end situation is, we cannot stabilize yet. So in that field, TNO is active and trying to be a partner for industry and public parties to make this transition successful, even though we don't know yet where it's going to end. So we're really working on optimizing for the future. We're working on upscaling and stabilizing solutions, and also helping with a controlled downscaling and phase out of current solutions that might not be needed in the future. TNO's scope of research is multiple years into the future. We don't work for next year, we work for 10 years, 20 years into the future. That is our real goal, to change the mobility system of the future. So, to start with our sustainable roadmap, sustainable traffic and transport, our focus for this roadmap is 2025. Like I said, we look further than that, but these are the steps we're focusing on for that time span. So 4 core elements that we're working on here. We want to support Dutch industrial R&D ecosystem, and of course the international ecosystem automatically with that, to realize sustainable mobility solutions on all levels I just described: vehicle solutions, mobility, and societal solutions. We want to support the sector, and this is very broad, can be the automotive sector, can be the maritime sector, but also logistics, to create sustainable mobility ecosystems. And we do that primarily by creating partnerships. TNO is a not-for-profit organization, so we're not doing contract research with parties and then stopping. We're actually building this ecosystem, bringing together parties, and then together trying to get government funding, trying to get to the right solutions, and we try to really make something change in the world. We also provide fact-based knowledge for effective policy making to our local governments, to Brabant, for instance, who's hosting today, to the cities in Brabant, but also to our national government and the EU. So TNO is very actively involved, especially on the sustainable side, on legislation. We had a big role, for instance, in helping set the Euro 7 standards. So we're really not just building technology, we're also creating knowledge and bringing that to our government. And we maintain state-of-the-art test facilities. With all of that, through our roadmap, as it's been shown there with the Plan, Do, Act, the Plan, Do, Check, Act circle, I'm saying the wrong order, we're supporting the transition that I just showed on the picture. We have 7 strategic deltas. I think time-wise it's maybe a little too much to go through them one by one, but these are really the highlights, the things that we are working on currently that have our most attention. So maybe good to show here for Japan. Hydrogen combustion technology, we'll get to that in a second, it's quite an important topic for us. Improved battery and fuel cell lifetimes, a very important one that also will be covered in the presentation, 2 presentations later about the Battery Competence Center. But also, for instance, the application of artificial intelligence in this field, and the logistic innovations that are quite important also for the sustainable side. Like I said, today's presentation is going to focus on the vehicle level, so I'm not going to go through everything here, but hopefully this gives you a little bit of an overview of what we do in our roadmap. If there's any questions during the presentation, don't hesitate to ask, by the way, because it might be difficult to get to that to the end. Please don't read all of this, but it's just to give a little bit of a feeling. If we're talking about making vehicles more sustainable, there's a lot happening on the policy side. So this is just an overview for the Netherlands on the things that are happening and have happened in the last years on policy. So new Euro standards, Euro 7 coming out. European Green Deal from the European Union, that's dictating a lot on what we can do emission-wise. But also from the Dutch government, also climate ambitions. Limitations on the sales of combustion engines for passenger vehicles, for instance. In the Netherlands, a very large issue, nitrogen deposition. So all of these things are happening, and the ecosystem, the private parties, but also the government agencies need to be able to support all of this. And it's quite difficult. So we're working there on a lot of changes, new propulsion technologies, new powertrain technologies, but also different applications because this policy drives certain directions. And TNO, with the combination between technology that we have, but also the knowledge we have of this policy field, because we're active there, gives a unique position to really build these ecosystems with the private parties. For us, on the sustainable side, we feel strongly that there needs to be a push to diversify the powertrain solutions. And with that, I'm trying to say is there's not going to be, at least until 2050, and maybe we can argue afterwards, that's not going to be a single solution that will support all modalities. Just focusing a little bit on on-road, especially on heavy duty, we can see that there is not a single solution energy carrier-wise, infrastructure-wise, and powertrain-wise that will work and that will bring 100% clean powertrains to the roads by 2050. There's simply not enough of one source available, so maybe not enough electricity, maybe not enough rare materials to build these systems. So we feel strongly that we need to have a mix of technologies that will meet these goals that are set by the policy, set by the transition, to be able to actually have the heavy-duty market function. A lot of times there's talk about electrification, and we absolutely believe that that's a big part of this solution, but it's not going to be applicable for all solutions in all markets, in all countries. So what we propose to go from the current situation, where the diesel powertrain is the all-rounder energy source for almost all heavy-duty transport, to go to a sustainable future in 2030, we say diversify. And just as an example, maybe in the urban regional distribution field, go for electrification, make smaller trucks, make them electrified. But then looking at the long haul side, hydrogen, either in combustion engine or fuel cells, could be very relevant. And we could make this picture much more complicated by adding additional axes. The main message I'm trying to say here is we shouldn't bet as a mobility sector on one horse. There will be multiple solutions. TNO tries to, let me click through this, tries to facilitate this by having knowledge and working on all of those powertrains. So also this I presented very briefly in my previous presentation. We work on hydrogen, both for combustion engines and fuel cells, on electrification, batteries, energy management, all of those things. But also we maintain state-of-the-art facilities to prove those powertrains. So a little bit more details on that. So we believe that the vehicle powertrain should be optimized for its usage, for its operational domain, so to speak. And we do that because we can do that because we have in-depth knowledge of the vehicle powertrain, individual components within that powertrain, and also the vehicle in practice, interaction with the mobility system in general. Again, on all technologies. We optimize with that knowledge the next generation powertrains, and we do focus on the transition from fossil fuels to renewable fuels, right? So we're not saying keep doing combustion engines the way they are being used now, but use these technologies to make a transition. If you create fuel flexibility in your system, then it's going to be much easier to get to renewable fuels. Energy usage, emissions, and total cost of ownership, we also optimize on those. In the end, of course, total cost of ownership is very important for the end user. We can make very nice emission-free solutions, but if they're not affordable for an end user, a shipper, a bus company, it's not a solution that we should consider. Oh, that goes very fast. So I think I've said that already, but focus on hydrogen combustion, battery electric systems, fuel cell electric systems, and hybrid combinations of those. And I'll get into the hydrogen combustion research a little bit more. And sorry, I didn't know that was under there. But also a very important thing we're doing is our self-learning energy management tool. If you want to develop systems for multiple applications, especially for OEMs that have smaller, smaller sets of vehicles, but multiple types of vehicles. You can think, for instance, of the non-road mobile machinery market, diggers, excavators, bulldozers. You want to be able to roll out all of those systems based on their usage, and then optimize the system for that particular application. And we've created a self-learning energy management tool that gives input in the development phase by creating reliable comparisons, so you can choose the right configuration, automatically generates the energy management strategies that can then be used in the ECUs of the systems to actually optimize on the road in vehicle. This is quite an important one as well. So like I said, a little bit more on hydrogen combustion. We believe very strongly that we need to make usage of the already mature and proven technology of combustion engines to be able to use a very important upcoming energy carrier. In Europe, it's already been mandated also by the European Union that there will be hydrogen available for the mobility field. If we look at the current development in fuel cells, We think it's unrealistic to believe that all of that hydrogen can be used in fuel cells for heavy-duty applications. This is due to the maturity of the fuel cells for those kind of applications, but also the things like the materials that are needed, the recycling chain of those fuel cells. So we believe strongly that we need another way to actually use that hydrogen and use its CO2 reduction potential. Because of course, hydrogen, even in a combustion engine, there's no CO2 output. So we think, use the combustion engine. It's already there. We can make it very clean. The only thing that you need to take care of in hydrogen combustion is the emissions, because if you burn hydrogen, you don't get CO2, but you can still get nitrous oxide emissions, particulate emissions. But with very clever technologies, we can bring that to near zero as well. And you have a great way of transitioning from maybe fuel cells in the future, maybe battery electric systems in the future, but to already use that hydrogen when it becomes available. So the roadmap we are following for that is on the slide now. We're developing currently these engines, and we're going to roll them out first in more stable, simpler applications like gensets, generators, pumps, agricultural equipment, maritime engines who also run more in steady state. And then in the future, near future, because we're talking 2025, it's not that far away, we're working with OEMs already in Europe on rolling out hydrogen combustion as a available technology in 2025 for dynamic applications. There's a lot on this slide. No, it was clickable. But just to give you a little bit of a feeling, if there's questions about this, you can always also come see me for this, but there's a lot of detail on here. Let's see if this works. Yep. So currently we are working in this orange bar on our research, which we're doing fundamentally on one-cylinder setups, so we have in our lab, to improve the combustion performance of hydrogen. We're working on a dual fuel solution where we can actually bring the nitrous oxide emissions down to near zero. So at the moment we have a demonstrating platform here together with DAF, which was already mentioned in the RAI presentation. That is already drivable, it's feasible, but we want to improve load range and response. So those are things, of course, that the users find very important, but we also want to reduce the emissions. So to get to Euro 7 levels on NOx reduction and efficiency. And we do that by doing this research and combining that, that's not particularly on this slide, with partnerships with OEMs worldwide to try to roll out this technology as fast as possible. What we expect is by 2025 to have a Euro 6 vehicle on the road that is feasible, that can be used already, and then very shortly thereafter to have the Euro 7 vehicle available so that we can meet all the legislations that are required for this technology. The Euro 7 legislation has come out already. It's very low particulate and NOx limits, so it's going to be a challenge. And the way we're going to do that is by running the engine not spark ignited, but dual fuel for those of you that are interested in petrol or combustion engines. So, what kind of activities are we doing to meet that roadmap? One of the things we're doing for our partners is platform conversion. So we're actually using this, the existing platforms of the OEMs and helping them re-engineer them for hydrogen. That's always a partnership. We don't build our own engines, but we can work with engines from third parties or from OEMs themselves to convert them. We have the test facilities to validate those setups, to do repeative testing. We also have there the abilities to do long run hydrogen testing, so with high capacity hydrogen flows, we can all do that in our labs. We're also, as I already mentioned, doing experimental research. You can see here, it's maybe a little hard to see, but our one-cylinder setup, so that is for a heavy-duty application-sized engine, where we do for one cylinder all the testing so we can actually see what's happening. And we also have a much bigger one cylinder setup for maritime applications where we can do much bigger volume. And there we do physical testing and simulations, compare those to come up with the actual models, and do the dimensioning and do the testing that is required to do these conversions, but also looking forward, what would be the next step? How do we design our next our next engine? And then we bring that to the road. That's always for TNO a very important step. We don't make theoretical models. We're not a university, we're an applied research institute. So we always work with partners, and I keep saying in this case DAF, who allow us to bring that technology to the road so we can actually see what happens in practice. So already, just for a little bit of a feeling, we demonstrated below Euro 6 NOx and particulate emissions with a brake thermal efficiency of 42%, which is not diesel equivalent, but high enough. And the only thing that we haven't done yet is the transient load response, so we're not set up for dynamic applications yet, which is, I'm just saying it's the only thing, but it's a big challenge, of course, to fix that. We have a very nice facility. You have to believe me for it now. But just to, I will show you, skip to some slides here. Just to give you a little bit of a feeling, our facility does anything from climate altitude testing to real world emission testing on the road. We have all kinds of fuel infrastructure, a very nice facility. If ever you're near Helmond, contact me and we'll arrange a tour. Smart vehicles then. So on the smart side, already presented also our focus areas, and I also want to give some more details there. So connected and cooperative, communicating vehicles, linking vehicles with road and data infrastructures and each other, so cooperative driving, automated yards, looking at localization, world modeling, planning and control techniques, and street-proof and street-wise, which I always like to name as one thing. They're two separate focus areas, but I think they're both equally important. Street-wise, to get vehicles to be designed in a safe way and to get them approved to be on the road for autonomous driving systems, and then street-proof to keep them safe and monitor the deployment and making sure that even after software updates occur, for instance, the system remains safe. So we always work in the so-called V-cycle, which to OEMs is very familiar. We start, of course, at specification, work towards implementation of our technology together with our partners on vehicles and also in system level. Test that, make assessments, also on urban level. This picture shows an urban assessment tool that we have, where we can actually see if we deploy this technology, what will happen in the city, what will happen with the flows of traffic, with the emissions, with noise, all of those things. And then we use the safety monitoring again to say, okay, if the solution in the assessments proves to be viable, is it still safe enough? And that sometimes means we have to change the specifications and go through the entire cycle again. Our mobility, smart mobility research center is something that we're currently building in Helmond. It's partly a physical location, a building, but it's also partly a on the road system. So a lot of test vehicles are deployed there. We're working on all kinds of fields there. So we have smart infrastructure available. We have instrumented roads around Helmond that have additional cameras, that have communication systems where we can actually do tests on the road. We have special vehicles driving around that do recording of all kinds of scenarios. We call that Street Live. So they're actually instrumented with additional sensors, and we use them to record actual situations on the road. We have test vehicles available, multiple types, just some pictures here, the Renault's car labs and DAF truck labs that we have, that we can actually use to do on-road testing. We have a large facility with hardware and software in the loop where we can do simulations with hardware components included in the chain. And we have a driving simulator available here that we can use for the human-machine interaction. For instance, the handover process for level 3 automation or level 4 automation. So one thing that's not on this row, but that's good to mention here, is that we also have a large facility that is on human well-being in vehicles. So when we're talking, for instance, about motion sickness and well-feeling, if you make an autonomous system, you also want to make sure that people feel safe in it and feel good. If the system really does weird braking, you can get nauseous. So we, from our defense departments, we have a lot of knowledge on the human body interaction in movement for instance, fighter pilots. And we have large facilities there also that can simulate all kinds of movement while inputting data. And there we build our models on the motion sickness side. All of those facilities are connected in our cloud solution, where we not just exchange the vehicle data, but also store all this information, make data also available to the vehicles. And on top of that, we have our safety monitoring for street proof, where we can see what's actually happening in the vehicles on the long term. We do our safety assessment tool chain for Streetwise. And then further on top of that, we can do traffic simulation and digital city simulation, where we can then bring together all of those test facilities. And for instance, see if you want to test one of your algorithms or your own vehicle, we can bring that in the test facilities and then actually test it through the entire chain and show that it's functioning well within traffic or that it's a good solution for a city. It's partly government funded, this facility, by the province of Brabant, by the way, so that's very good to mention here as well. We're very happy with that support, but it's also very much a partnership with the private industry. And that was it.